Okay, so one athlete's running the 100-meter dash, another athlete's running a pretty different race, an 800-meter dash. One's about all-out speed, and one's more about regulating that speed for a longer distance. So obviously they can't compare their times and say who's fastest. What they want to do is they want to compare their times to the other kids or the other adults or the other athletes in their group, and then they can decide who's the better athlete, like as if it matters, which it does not. Uh, okay, so what you want to do is calculate a z-score. You take the number you're converting, subtract it by the mean, so we usually use Greek letter mu for that, then divide by this Greek letter sigma. We like to make Greek letters because math teachers are trying to get job security, and we think if we throw Greek letters in, then you'll need us. So all this means is the mean for the group. And all this means is the standard deviation for the group. And if this is your first time hearing the word standard deviation, a standard deviation just means it's a measure of how spread apart the data set is. Okay, so how spread apart the numbers are. If you got a big standard deviation, that means the numbers for this race are all over the place. So when you make this calculation, it's like you're boiling down the numbers to a comparison of everything else in your group. If you get a positive z-score, a pretty big one, that means you're well above average. A negative z-score means you're below average. So let's do the 100-meter athlete first. Their time is 10 minutes and 52 seconds, so I'm plugging that right in for x in the formula. What did they say the mean? Race times for the 100-meter dash have a mean of 11.2, so that's what I'm going to plug in here. Sorry, 11.24. And a standard deviation of 0.7, so that's what goes in bottom. And so we can use our calculator. So I hit enter first, and then I hit divide 0.7. So I got negative 1.03 roughly. Okay, so this this person got a negative z-score. That means they're a little bit below average, and we can see that because they ran their time within 10 minutes and 52 seconds. And I shouldn't say below average because a smaller time means you ran it faster, so that's good. I guess below average might instantly mean in our heads that they did worse. And now let's do the same thing for the 800-meter dash person. Their time was 109 seconds. The mean time for the 800-meter dash is 118 seconds. And then divide it by 3.7. Okay, so 109, subtract 118, hit enter, and then divide 3.7, so negative 2.43. So what the z-scores allow us to do is to compare the times in two different races. Relative to the other people that are running these events, the 800-meter dash guy got a much more significant smaller time, negative 2.43. They were below the mean time by more than 2 standard deviations is what that means. So in the context of a race, a negative z-score would be better because you're trying to get a time below average. The faster you run, the better, I don't know, the more your parents love you. Okay, so the z-score of negative 2.43 is best for this one because we're running a race. If it was like shot put, you want to throw it further, so you'd want a bigger, a more positive z-score, right?